So with neurons, for example, our neurons are very, very, very positively charged. And so what will happen is you get rapid depolarization where a negative charge from sodium rushes into the cell. And then from there, a negative charge, rapid negative charge gets thrown down the neuron because of all the sodium. And that's what allows our nerves to fire. When that's the case, you reach the end of the neuron where you have these little finger-like projections, and you open up, they're called voltage-gated calcium channels. And these voltage, man, I can't talk today. Voltage-gated calcium channels will open up and allow calcium to move in and spit out neurotransmitters. When that's the case, your nerves communicate with one another. So you have something called a synapse, where you have finger-like projections from one neuron, spits out neurotransmitters into something called the synaptic cleft, which is just space between them. And then from there, the other neuron on the other side will sense these neurotransmitters, and that will start the same negative charge that carried down the first neuron into this next one. And so it's this never-ending chain of firing of these neurons due to sodium and potassium. So the gradient between negative sodium and positive potassium is what causes our brains to work. It's what causes our muscles to fire. It's what causes our heart to beat. You know, it's all of these super basic necessities of life that are attributed to electrolyte balance.